How are we doing today? This is going to be an interesting lesson because this is designed just for you since I'm not here today. We are going to make sure that we are going to try to use our resources today to learn on our own. So whether you have me or Mrs. Michaels or Mrs. Adams, this should be an interesting challenge for you guys. You're going to watch your video today. You're going to see these examples, and then you're going to attempt to do your work in Delta Math. Of course, the bells are still ringing, even though there's no one in school today. It's interesting. All right, so let's start to look at this 2.4 shapes of graphs. And if you really need to know our benchmark, there you go, whatever good that does you. Now, we have to realize, okay, so for some graphs have a very symmetrical pattern as we look at them. Again, it's like a picture. A graph is a picture of all possible answers, and all these answers are coordinates. X's and Y's. X's are what you plug into your equation. The Y's are what you're getting out of it. And as we start to plot all these possible answers, they start to form a picture. And like anything else, you can look at a picture and sometimes say, hey, I can tell that this thing looks symmetrical. And as we do that, you should be able to start to see interesting things, all right? If it is absolutely symmetrical, it is like a nice mirror image on one side. We're going to draw a vertical line, just like the vertical line test. And there might be a point on this line where we can actually cut it in half, and it looks like a mirror image on both sides. And we like to write this as a vertical line, okay? X equals, you have to put the X equals, okay? It's not a line if it doesn't have X equals. X equals is the equation of a vertical line. And A, well, this A right here, A is, well, where does this line cross your x-axis? So let's start to look at some of these first ones here, right? If we are looking at this, right, we're going to go through here and, hey, I can tell that this looks pretty symmetrical. Now, it goes on and on forever in both directions, but look at this part. I could literally cut this graph in half right here. Right like that. Okay, and if I look very carefully, does this line have, is it a line of symmetry? If you look at the left-hand side of it, you look at the right-hand side of it, see the left-hand side of it. The right-hand side is every point reflected perfectly over this line. This one is 1, 2, 3 from the line, 1, 2, 3 from the line. If you went from here, 1, 2, 3, 4 to the line, 1, 2, 3, 4 to the line, and that's all the graph does on this side. So yes, this absolutely is a line of symmetry. And if we needed to write the equation of this line, you want to say, well, where does this line intersect the x-axis? And it's an x-intercept right there at the value of -1, right? If these are going by 1. So to write our answer, we'd say the line of symmetry is x equals -1. That easy. Now look at this one. Example 2 is interesting. I could draw a vertical line anywhere, but look what's left. Does this side perfectly mirror image this side? So no, there is no symmetry going on this one. It literally has to look like an example 1. It has to be the duplicate of the other side. It cannot be different. I think that's a pretty easy concept for us to get. Human beings are generally drawn to symmetry. The hard part is writing this equation. And where does that line of symmetry intersect the x-axis? What is its x-intercept? -1. X equals -1. That's how we write it. So again, notice in order for this line symmetry, in order to have line symmetry, it must be a mirror image. And again, that is so, so important. Notice this one. This one looks like it sort of has symmetry, right? I can say, oh, look, I have a lump here, and then it goes down. If I were to draw that line right through here. But notice, it isn't completely, it's like reverse symmetry in this one. Don't let this one fool you. if you consider this right here to be like the piece of paper, you're going to fold the piece of paper in half. It has to be a mirror image. This is like a reverse image, an inverse image here. Not. This is no symmetry here. Not symmetrical. No. No symmetry. Okay. As we start getting these graphs, guys, you have to realize graphs are read just like we read books, okay? We read graphs from left to right, just like a book. And the best thing to do is trace it, like this one here. We're tracing the line back and forth, back and forth. We start on the left, put our pencil down or our finger, and you trace the line, just like I'm doing here. As you trace the line, start to describe what the graph is doing from left to right. It could be doing a few things. It could be increasing, it could be decreasing, or it could stay constant, right? Look at this one, up. If you consider this to be a mountain, right? A little man climbed the mountain. Then suddenly he gets to the top, and then there's a turn. Now he's going down the mountain, and then he's in the valley, and he stops, and now he has to climb back up the mountain again. That's how you want to kind of describe these. Increasing, decreasing, increasing. Graphs can keep oscillating between these. And once in a while, of course, maybe it could pan off and it could be like your x-axis is constant. That doesn't change at all. All right, so let's see how this works. We can also look as we're reading these, like from here to here. You know, these are changing over certain x values. From this arrow is pointing down, which means it goes this way forever, from like infinity. And as you're increasing from negative infinity all the way until you get about right here, which is like, what's it, 1 3/4-ish? Negative 1 3/4. And then what happens? It stops, and then it changes. And now it starts to go downhill until you get to about here, which is like 2. And then it stops and it changes. So all these change, these points at which they change direction or they change their increasing and decreasing are key points on the x-axis. And we can write these and represent these with inequalities. Let's see how it's done. Okay, look at this one. So we're going to do it left to right, right? Put our cursor or our pencil on the left-hand side, our finger, and we're going to trace. Say, okay, what are we doing? Going up? Are we going down? I think we're going down. I'm decreasing, decreasing, decreasing. It's less of a decrease, but look, I'm still decreasing, still decreasing, still decreasing, still decreasing forever. So this graph goes, notice the arrow, right? The arrow is a key part. It's going in this direction forever. So from negative infinity and it's going in this direction forever to positive infinity. Write it like this. This is called interval notation. Sorry. Like us teachers are doing anything, they still interrupt us during the day. We could also say this is all real numbers. So all values of x, all real values of x. All right, let's look at the next one. This one, we clearly see there's a difference here, right? We start on the left, and we're going to go up. Up, 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 up. Oh. And then we're going to come down, 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 down. Right? Increasing, and oh, there's a change. And then we start to decrease. Well, let's see, where does this change take place? It looks like it's taking place. I'm going to my x, but right there. So that's like 1, 2, negative 2.5. So if we want to write this in inequality notation, the graph is increasing, meaning on this side, right? Because this is where it was going up, increasing for any value of x that is less than 2.5. Think of it on a number line, right? From here, this is how we drew it when we solved inequalities in this direction, right? Using the x-axis as our number line. From -2, from any number less than -2.5, this graph is increasing. If they want to say about the decreasing side, right? Let's change this so that we can change colors. All right, so this was our decrease. Now, if they want to say when it's decreasing, right? Same thing. Look, where is our change? Our change on our x-axis is happening right here at 2.5. And it starts decreasing forever and ever and ever and ever in this direction. Right? So we can go through and say, okay, so for this one, it's decreasing for any number of x that is greater than, see how the arrow points that way, greater than 2.5. If you wanted to write this one, our first one in inequality notation, you could go like this. Negative infinity is less than x, which is less than positive infinity. Just the side note. Okay, so this here again, this was the value where it was increasing. So for any number that's less than 2.5, this graph from somewhere down here in negative infinity all the way up till you hit this special point. It's like it's the top of the hill. We'll talk about that a little bit later. Is when it's increasing. And then all of a sudden we get to that top and it changes direction. And that's when it starts to go downhill. So whenever where x is greater than, these are again more negatives, negatives 2.5, it starts to decrease forever and ever and ever and ever. All right. Let's look at this one. I want you guys to stop. You guys try example 6 and let's see. Give it a minute. Write your inequality notation for when it's increasing and when it's decreasing and which side is which. All right, let's see. Did you guys get it? I don't know. Let's find out. So here we go. If you read your graph again, trace your graph. What is that cursor doing? It is going up or is it going down? As our x's are starting to increase, right? These y values are starting to decrease. So it is decreasing all the way until it hits here. And again, we don't know where this is, so let's track it back up to our x-axis. This is 1, 2. It's about right in the middle of 1 and 2, about 1.5. So right here is that key point, right? So for any value of x that is in that direction less than 1.5, it's decreasing. I'm just going to write a D for decreasing. Now, what about from here? At this point, it changed, right? And then it starts going up again forever. So that same point, 1.5. Remember, if we were to write the line this way, for any value of x that is greater than 1.5, the line is increasing. And that's how we do it. We're kind of using something we learned from the past, concepts, and blending it in with this current new topic about an increasing and a decreasing graph. And to be honest, some of this you should have really learned if you were in Algebra 1A or maybe pre-algebra, that graphs can increase, graphs can decrease, right? Related to its type of slope, right? A positive slope, it increases, negative slopes, it decreases. It's all from pre-algebra. Right, let's keep going and let's see what else we have to learn today. Okay, here's a refresher from our last class. Okay, remember, from 2.3 with graphs also have positive and negative They're also positive, negative on certain intervals of x, just like they can increase and decrease. They're positive and negative. And that just simply means that when you plug in the x, is your answer going to be a positive answer or a negative answer? And they want to know that. And again, it's the key points. It's those x-intercepts that are determining that for us. So again, look at this graph. Let's identify our x-intercepts. It's the first thing we do, right? Right here. Boom. There is an x-intercept right here. Boom. There's an x-intercept. So that's at 3 and at 7. All of our answers rotate around those, right? If it says positive, oh, this one actually is asking us to find negative. So notice negative. Negative is this spot here. This is when it's negative. That's the section of the graph that is below the x-axis. So we start all these numbers anytime we plug in from 3 to 7. Any number we plug in between from 3 to 7 creates a negative answer. So when we have that, we are good to go. So we go from here, you have 3 is less than x, which is less than 7. And like that, you have the ability to determine that. We can also, just for fun, write these, right? When you have this side over in here, we have the ability to sit here and determine when we're going to have positive and negative values. So look, here is the positive side. These are the two pieces of the graph that are above your x-axis. So we can write it like this, at right there, 3. When x is less than 3, it's positive, or when x is greater than 7, it's positive. And away you go. It's just determining, looking at the graphs again. That was a refresher from the last lesson. Probably the most confusing thing we did last lesson, but with practice, it gets easier, guys. Example 7. Now, when we look at these next examples, or example 8 and so on, right? As this, we can use these graphs and the directions that they go in to help us predict what's happening to our x and our y values. In other words, they like to ask us like this: as our x's is getting larger or going towards, infinity, so as x is starting to get larger or go towards, well, that's infinity on this side over here. They want to know what's happening to our y values. So look at this. Every time we start going here, right? There's our value. That's where the endpoint is. You go to 7, and it's going up here. If you go to 8, it's going to probably be like up here. Go to 10, it's way, way up here, and so on and so on and so on. So you look at the end of the graph and you say, okay, when they're saying, hey, x is getting larger or x is going towards infinity, look at the end of the graph and determine, look at the arrow. Which direction is that arrow pointing? It's pointing up. So as your x's keep coming this way, the values of your y's keep getting higher, higher, and higher, and higher, or they're going towards infinity. Positive infinity. Look at this side of the graph, because next, they also ask us, like, what happens when x is getting smaller or it's going towards negative infinity? Well, on this side of the graph, as these x values keep moving in this direction, look at the end of our graph. It also is going up. So as every value of x starts increasing, this graph gets higher and higher and higher. So both of them end up going towards infinity. So you could say this might be what the answer looks like, for this side here. It was like, as x is approaching infinity, it's kind of what the arrow means, or going towards infinity, they want to know what's happening to y. Right? Y is going in which direction? Well, we can say, oh, it's going in towards infinity. On this side here, as your x's are approaching negative infinity, or your x's are getting smaller, right? Your y's are also, they're approaching positive infinity. So as your x's are getting smaller, your y's are getting larger. On this side, as your x's are getting larger, your y's are also getting larger. You read the graph and it tells you what to look for. All else fails, any point on this graph here, you start here, -9, and you can trace it back to 14,406, right? Go over 1 up here. So -10, 57,624. Notice your y values are getting larger every time. It's how you find points off a graph, guys. Let's try another example of this. End behavior of graphs. Well, look, this one looks totally different. They want to know. Let's do both here. I'm going to do on this side of the graph, as your x's are getting larger, or as they're going towards or approaching infinity. Where are your y's going? So I want you guys right now, track this graph on this right-hand side. So as your x's are starting to get larger, so this is where the graph kind of veers off. What happens when we go to 9 from 8? Right here at 8, right? It's 8, 0 is our y coordinate. At 9, what's our y coordinate? Is it larger or is it smaller? That's for you to figure out. Track up to the graph. What did you get? What do you think? What about 10? When x is 10, where do you think? Now we can't see it. Where do you want to predict, right? Probably about here, and then maybe 9, 10 way up there. Yeah, your y values keep getting bigger and bigger and bigger. At this side, as our x's are starting to get smaller, or as they start to go towards negative infinity, right? Because that's this direction. Look right here, right? 2, 0. Then we jump over 1, getting smaller. Wow, that really starts to drop. If you go here, that's really somewhere way down there. Really a bigger negative number. So yeah, what's happening as our x's are getting smaller? And look, the arrow points the way. It's going down. The y values are getting smaller. Y will also approach negative infinity. So we have to just think about that, guys. It's an interesting concept. It's just about reading graphs and figuring out what's going. Basically, any number we plug in, that's this direction, that gets smaller and smaller. Those y's are going to be exponentially smaller, smaller and smaller and smaller and smaller, till they eventually someday approach negative infinity and beyond. Another thing we have to think about, guys, is remember those magic, when we were talking about the increasing and decreasing above, there was that magical point where all of a sudden, like, there was a turn in the graph. We were no longer increasing, we were decreasing. All right. And those are called extremes. Whenever there is a change in direction in our graph, as we're reading our graph from left to right, and we notice a change in direction, that's considered a relative minimum or relative maximum, depending on where it kind of sits. Are you in a valley or are you on the top of a hill? Right, and that's what we need to start to look at. So let's look at this graph, just reading along, and they've done a really good job. They've identified key points for us here. So we are sitting here heading down, down, down. We're decreasing, we're decreasing, we're decreasing, we're decreasing. I mean, that was an important point, but we were still decreasing. Remember, that's an x-intercept. Hint, hint. Decreasing, decreasing, decreasing. We get to B, and suddenly there's a change. So this is super important. There's a change, right? We were decreasing, and then all of a sudden we change, and now we're increasing, 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 and here we go again. There's a change. Then we're decreasing all the way to here, and oop, we hit another special point, and it turns, and now we're increasing again. So notice, extreme points are these points where the graph radically changes. It's a complete change from a decrease to an increase or an increase to a decrease. Those key points are given two terms. They're either maximums, relative maximums, or relative minimums. Sometimes there could be more than one of each. You don't know. You have to look at it and see where does it fall on the graph. Well, notice, this is like you're climbing downhill, 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 and you're in a valley. Can you go any lower than B? No, that's about the minimum you can go is B. And that's exactly what that's called. This is a minimum here, a relative minimum. Abbreviating, relative minimum. And then look what C. C is the top of a hill. Can you go any higher than C? No, it changes direction. This we call a relative maximum. And I think this is a concept that most students get pretty easy because it's kind of common sense. It's a minimum. You can't go any lower than that. So it's a relative minimum. Relative maximum. No, just there we go. And then look, we had one more that we circled that was one of those change. Again, this is at the bottom of another hill. So again, this is another relative minimum. And if you want to be specific, sometimes they ask us, this graph would have two relative minimums. So your relative minimum, and I am abbreviating this, guys, a relative minimum, there are two of them on this graph. Separate your answers using a comma. On our Delta Math, of course, it would open up your solution set. It's the point B is a relative minimum. Point E is a relative minimum. There are two. And then if you're dealing with the relative maximums, they're asking you to identify those. In this case, we only have one. That is point C. C would be your relative maximum, and there's only one of those. All right. That is pretty much it for this lesson, guys. This again is an easy concept. The ones where we're talking about end positions, it's not hard. We just got to wrap our brain around it, and we have to practice our homework. So it's all about you. Do you want to do well? Are you going to do the studying that it takes to be a good math student? Because there's no such thing as a bad math student. There's bad homework preparers. I mean, if we don't do our homework, we can't expect to be great at math, right? Because that's our only practice. So get out there, make sure you get your Delta Math done, and do your homework, guys. Have a great one. See you guys tomorrow.